Today, we're going to pull back the curtain on one of the trickiest puzzles in modern medicine. How in the world do you test a vaccine for a deadly virus? We're going to use a real, fascinating HIV experiment as our guide. And trust me, it's a brilliant story about scientific problem solving. All right, so let's just dive right into the core problem. Imagine you've spent years developing what you think is a great new vaccine. Awesome, right? But now you have to prove it works. And what do you do when the virus you're fighting is something as dangerous as HIV? Well, you're looking at a huge ethical minefield. So let's do a quick refresher on what a vaccine even does. Think of it like a training simulation for your immune system. It gives your body a little sneak peek of the enemy, a harmless piece of the virus, so it can learn to build up its defenses, which we call antibodies. That way, if the real deal ever shows up, your body isn't caught by surprise. It's already armed and ready to go. And this, of course, leads to the obvious but pretty horrifying question. If you really want to know for sure, beyond a shadow of a doubt, that your vaccine works, do you have to give it to volunteers and then actually expose them to HIV? The answer is a hard, absolute no. You just can't do that. Intentionally infecting someone with HIV is completely, totally forbidden. As the source material says, it'd be like handing them a death sentence. It's just not something science allows. Period. So the scientists had to find a much, much cleverer way to get their answer. And that's where our story really begins. Let's travel back to 2009. A group of U.S. scientists launched this massive HIV vaccine trial in Thailand. And this is a perfect example of the scientific method at work, which, by the way, almost always includes hitting a big wall first. And when I say massive, I mean it. We're talking about 16,000 people, 16,000 brave HIV-negative volunteers in Thailand who signed up for this trial. That number alone tells you this was a huge, serious undertaking. So let's imagine what Plan A might have looked like. It seems pretty straightforward, right? You get your 16,000 volunteers, you give the vaccine to every single one of them, you also teach them all about safe practices to prevent HIV, and then you just wait, say for 3 years. Then you look at their infection rate and compare it to the national average. Simple. I mean, on the surface, that sounds perfectly logical, but hiding in that simple plan is a giant experiment-ruining flaw. Just think about it for a second. Can you spot what's wrong with that comparison? And there it is, the fatal flaw. The two groups, your volunteers and the general population, they aren't actually comparable. Think about it. Your volunteers got a ton of education on how to prevent HIV. They're probably being way more careful than the average person. So their infection rate would likely be lower anyway, vaccine or no vaccine. You'd have no way of knowing if it was the shot or the education that made the difference. So how in the world did they solve this? Well, this is where the real genius, that secret trick, comes into play. It's a fundamental idea in science that allowed them to design an experiment that was not only ethical, but that you could actually trust. Here's what they did. Instead of one giant group, they split the 16,000 volunteers right down the middle, creating two perfectly matched groups. 8,000 people got the real HIV vaccine, and the other 8,000, they got a placebo, basically a fake shot, just a harmless saline solution. Now, everyone gets the same education, everyone lives in the same areas. The only difference between Group A and Group B is that one got the vaccine. That's the key. But wait, it gets even more clever. They made the study double-blind. Now, that means the volunteers had no idea if they were getting the real vaccine or the fake one. But here's the double part. Many of the scientists and doctors running the trial also didn't know who got what. This is so important because it gets rid of any bias, even unconscious bias, that could mess up the results. It's pure objective science. Okay, so fast forward 3 years. You've run this incredible, double-blind, placebo-controlled trial. The data is in. What's the verdict? Did the vaccine actually do anything? This is the payoff. For the first time, scientists could compare two groups that were identical in every way, except for the vaccine. And when they did, they found a clear difference. The group that got the real vaccine had a noticeably lower rate of HIV infection than the group that got the placebo. It worked. So what was the magic number? The results showed that the vaccine reduced the risk of getting HIV by about 31%. Now, that's not a perfect cure-all, but it was huge. It was the first time ever that a vaccine had shown any real preventative effect against HIV. It proved that it was actually possible. Look, that 31% is a historic number. But honestly, it isn't the most important lesson from this whole story. The biggest takeaway is about how we got that number. It's about what makes any scientific study something you can actually believe in. So, this is what it all boils down to. Next time you read a headline about some new health study, here's your toolkit. Ask yourself, was the study big enough? Did it have lots of people? And here's the most important one. Did they have a control group, like our placebo group, to make a fair comparison? Without those things, you should probably take the results with a grain of salt. So there you have it. You're now in on the secret tricks scientists use to get real answers to really hard questions. The next time you see a news story about a medical breakthrough, you'll know exactly what to look for. Thanks for joining me on this one.